Hello everyone, my name is Billiot and this is our Mod 4 assignment for SATC420 Management Systems due December 5th, 2025. The incident I'm covering is the Williams-Olefins plant explosion and fire accident that occurred at the Williams Company Incorporated in Geismar, Louisiana, which was in Iberville Parish on June 13, 2013. The final report was released by the CSB on October 19, 2026, a little over 3 years later. The accident type was a chemical manufacturing, fire, and explosion, and the investigation status has been closed out, and once it was completed, the CSP held a release and news conference in Baton Rouge, Louisiana on October 19, 2016. Due to the incident, there were 167 injuries, 2 fatalities, and a release of greater than 30,000 pounds of hydrocarbons. The initial proposed penalties that OSHA recommended was attempting to enforce was $99,000. However, upon final negotiation of the incident, OSHA knocked it down to $36,000. However, in total, due to lawsuits by personnel that were directly affected by the situation, the incident, there were greater than $30 million in lawsuits that were granted out to personnel and families. An overview of the incident is that on June 13, 2013, a catastrophic explosion occurred at the Williams-Olefins plant in Geismar, Louisiana, resulting in 2 fatalities and injuries to 167 individuals. Prior to the incident, operations personnel noted a significant drop in systems pressure during the shift. Although the issue was flagged and efforts were made to engage maintenance to address suspected fouling within tubing bundles, a system supervisor introduced steam heating to a reboiler that had been offline for 16 months. Unbeknownst to the supervisor, propane had migrated into the shell side of the bundle, which was assumed via mistakenly open valve, leading block valve, or another unknown mechanism. The introduction of the heat caused propane to rapidly vaporize, leading to a boiling liquid expanding vapor explosion, or bleed, and which also led to the subsequent fire. Upon the investigation, the CSB came back and found the following PSM regulations as being not followed or was not adequately enforced. Process hazard analysis, operating procedure, pre-startup safety review, and management of change. So, an explanation of the PSM elements as discussed by CSP's investigation. Upon their conclusion, they noted the following: that Williams did not perform an adequate MOC for 2 significant process changes involving the propylene fractionator reboiler, nor did Williams install instrumentation to detect process fluid within the reboiler. Also, Williams performed a partial PSSR only after the bundles were brought online 12 years earlier. Williams did not adequately implement action items developed during a PHA or recommendations from a contractor pressure relief system engineering analysis. At that documentation showed it was a concern, but key personnel failed to follow up on the problem. Lastly, Williams did not perform a PHA or develop an operating procedure before the operational activities conducted on the date of the incident. Lessons learned from this event are as follows, as brought up by the CSB. Overpressure protection. Ensure all pressure vessels have effective overpressure safeguards such as pressure relief devices to prevent exceeding design limits. 2. Gate valve risk. Closed gate valves can leak or open accidentally, allowing process fluids into an offline equipment. Use robust isolation methods like blinds for better protection. 3. Verify PHA action items. Confirm that the process hazard analysis action items are implemented correctly and address the identified safety concerns. 4. Effective MOC practices. Conduct thorough management of change reviews with multiple multidisciplinary teams before implementing changes to identify and mitigate hazards. 5. Thorough PSSRs. Pre-startup safety reviews should verify proper installation, configuration, and safety measures before equipment is operational. 6. Detailed operating procedures. Develop clear, detailed procedures for critical operations, ensure proper training, and enforce adherence to those procedures. 7. Hierarchy of controls. Prioritize robust safeguards like pressure relief devices over administrative controls like car seals, as they are more reliable. 8. Process safety metrics. Use leading and lagging indicators to measure and improve the effectiveness of process safety management programs. And 9. Vigilant in PSM implementation. Consistently and thoroughly implement process safety management programs to prevent overlooked hazards that could lead to catastrophic incidents. And as far as references, these are all of the references that were used to conduct the research for this project. Thank you.